Hi everyone, we're going to now work on some cosine rule and mixed problems. So first we're going to establish the cosine rule. So looking at this triangle here, we're first going to start looking at triangle CBD, so that's this part. And by Pythagoras we know that a squared equals h squared plus x squared. If we rearrange for x, we find that x squared equals a squared take h squared. We'll call that equation 1. Then looking at triangle ABD, we know that c squared equals h squared plus this length here, which is b take x all squared. I multiply out the bracket, we'll get this expression here. Simplify, we'll get to this expression there. Now what we're going to do is we're going to substitute x squared into this equation. This x squared here becomes a squared take h squared, which is that there. Now if we simplify this expression, we end up with a squared, well the h squareds will cancel out, a squared plus b squared take 2bx. Now looking at triangle CBD, we find that cos c is equal to x divided by a. If we rearrange that for x, we find that x is equal to a cos c. Substitute a cos c into this expression here, and we'll end up with c squared equals a squared plus b squared take 2ab cos c. Now this is the cosine rule. Similar if we follow the same instructions but with different triangles, we end up with a squared equals b squared plus c squared take 2bc cos a, and b squared equals a squared plus c squared take 2ac cos b. And we notice that in all three of these there's a pattern. Whatever the values we have out the front, take the other two sides of the triangle, square each one, subtract 2 times these two sides multiplied by the angle between them. So if this is side A, this is side B, C is the angle between them. Similarly for A, C and B, A is the angle between them, so on and so forth. So let's have a look at this problem and what makes it a cosine problem and not a sine problem. If it's a cosine problem, we'll find that we're looking at all three sides and an angle. In this case, x squared, this side, will be equal to this side squared plus this side squared, take 2 times this side cos the angle in between them. So that's how this is constructed, and if we solve that, we get 2302. So I did over here on the calculator, remembering that that's this side squared, we have to take the square root to find out the value itself. And that's where the 48 millimeters comes from, to 1 decimal place. As we said in the preliminary exercise, we shouldn't show precision that's more than what's actually possible from the measurements. The measurements we were given were to no decimal places, therefore to do it to 1 decimal place is appropriate. Example 2. Same drill. 3 sides and an angle, indicating it's a cosine problem. Looking for x, so this side squared is equal to these 2 sides, each squared, subtract these 2 sides times 2, cos the angle between them, which is cos x. We could rearrange it and then punch that into our calculator. I think I've been lazier than that and just put this equation here, and you can see how it's starting to scroll, and then solved it. Now, we don't have to worry too much about it being between 0 and 180 because we know that some of these angles are going to be negative, and we don't have to deal with negative angles when we've got a triangle. So we're going to get one solution, but they can be between 0 and 180. And so the one solution in this case, the one positive solution, is going to be 85.39 or 85.4 because we're only going to work to 1 decimal place because that's the precision we've been given, or thereabouts. Don't forget to put your degree sign on. In the same way up here, we should remember to put our millimeters on to show the units. Example 8, we're now starting to get into composite problems and mixed problems. So we've been given that BAE is a straight line. Now, given that, we know that for the triangle BAC, specifically this angle here, plus the angle in CAD, this angle here, plus the angle in AEAD, that angle there, should add up to 180 degrees. We're going to use that property to find this side x that we're trying to get. So Starting with triangle BAC, trying to find angle BAC, because until we've got that angle there, we're not going to be able to find x. We've already been given the other two sides, so we need that angle to make a cosine problem up. Can't solve it as long as there's two unknowns. So finding that angle there, 68 squared is going to equal to 38 squared, 37 squared plus 41 squared. Take 2 times 37, 41 cos angle BAC, the angle between them. Solve that, we'll get 121.25. There it is there. Then doing B, what are we doing? DAC now. It's doing this angle here. No, we can't be doing that one. Must be doing DAE, doing this angle here. 21 squared is equal to 33 squared plus 48 squared. Take 2 times 33, 48. That gives us angle DAE. That's that one. Now we know we can find this angle here by subtracting these two from 180, which tells us that DAC is 37.47. There it is there. Now if we want CD squared, that's going to be this side squared plus this side squared. Take 2 times those times cos 37.47. Is this here? Then that gives us an answer of 622, which is here. Take the square root of that to get side CD, which gives us 25.0 millimeters. Remembering that having precision much more than 1 decimal place is inappropriate, given that we've only been given it whole numbers for all the measurements. Example 9's a lot simpler, thank goodness. So we need to find a squared equals blah, solve it, get 16.73, a is 4.09. Now we have to solve the triangle, so we also have to find angles B and C. Angle B can be found the same way. Now that we've got side A, gives us 84.6. To find the remaining angle, just subtract them from 180 degrees, and that gives us 60.4. It's quite common to have to subtract from 180 to get the third angle in order to get the angle you require to use the cosine rule. Before we finish up, some vocabulary to help you solve the problems in 10C. If the word subtens is used, it's describing a line that is opposite the angle. In this case, the line AB subtends angle ACB at C. It's used more with circle geometry. So chord DE subtends the angle DFE at center F. And now the at comment makes some sense. So subtends is one of those words that's confusing unless you've actually been exposed to it. A cyclic quadrilateral has some specific properties. It's a quadrilateral inscribed on the inside of a circle. The opposite angles, C and D and A and B, add up to 180 degrees. And we use that property to solve some problems, especially when we're trying to construct triangles. Alright, that's all you need to know to attempt the first 10 questions of, the second set of questions from 10C. There's a fair few of them and they take some time, so it's good probably to start before the exercise is due. Thanks everyone.